All right, howdy. So I do need you to pay attention to this guy. So pay attention, please. This is going to be a good lesson. What we're going to do today is we're going to work on finding the area of some composite shapes. So if you were in class with us last week, which I think just about everybody was, I'm not sure we had too many people on the absence list. We had to see everybody in person. That was great. But here we go with finding some area of composite shapes. We're just going to do a couple of these together, and then we'll probably have some for practice coming up here shortly. So as you can see, the first question says, and yes, this is found in our books. This is found in the activity 3 area, 3.2, I believe it is. 3.2, and I'm not quite sure the page number off the top of my head, but I'll put that in here later on in the video. So a figure is composed of a rectangular shape in the middle and then 2 semicircles. And the semicircles, clearly, that's going to be a half circle. So determine the area of the figure. I'm thinking that as you look at this, you should be able to tell that this piece right here is 6.5 centimeters and that this across here is 13 centimeters. If we were to kind of break this apart, I'm thinking that we could do the area of the rectangle, and then we can add something to that to get to the full answer. Okay. Now, I hope that you're able to kind of see that this is a semicircle and that over here is a semicircle. And if we put this semicircle together, that's going to equal just one full circle, right? So really just 2 half circles. And there's one there, and then that piece goes over there. So with that in mind, really we just need to find the rectangle and then add on a full circle. So let's do that. What I want you to do is to pause the video here, or stop the video. I'll actually probably have this in an ed puzzle, so you'll be forced to do so here in a moment. And I'm going to ask you for the answer. I want you to go work this out yourself. I want you to think to yourself, if 6.5 is all the way across, that's going to be this value right here. That's going to be all the way across. That's the diameter. Think about what is the radius then. And then remember, we're going to need that radius to use in our formula. The formula, remember, is area equals pi times the radius squared. So go take a moment now and find the answer for me. With the entire area, the area of this entire figure. Okay, so you can tell from what I've got on the screen here that the circle, which is all the way around here, and it's going to be these 2 semicircles put together, if the diameter is 6.5 centimeters, then the radius is going to be half that value at 3.25. We're going to take 3.25 as the radius. We're going to drop that into our formula underneath the R. We're going to square off the radius. So the radius squared means 3.25 times 3.25. We're going to multiply that by 3.14, and right here it is, 33.17 centimeters squared. 33.17 centimeters squared is going to represent just the area of the circle, meaning here and here. So we're going to need to take our 33.17, and we have to add this rectangular space in here. So whatever 6.5 is times 13, that's how we find the space for this rectangle. We're going to add that right in here. So then the final answer is 113.67 centimeters squared. And again, it's an approximate answer because A, we rounded the decimals, and then B, we used the 3.14 for circle, which is, again, approximate and not using it as an exact answer. Exact, we would leave it in terms of pi. Okay, so let's try another problem now. Okay, so number 2, a figure is composed of a trapezoid and a semicircle. Determine the area of the figure. There is a lot of different ways to get to this answer. So whether you go find the area of the trapezoid and the semicircle and add those together, so we could be looking at this trapezoid, and we could do it as a trapezoid. That's certainly a doable situation here. We could do that, okay? Find that trapezoid, and then you could use the formula for the area of a trapezoid and then add on this half circle. And yes, you would need to find the area of a half circle, not a full circle. And you can put those together and be done. Could you find this triangle right here? Absolutely. So we could look at this as a triangle and find that triangle measurement right there. We could kind of do the same thing over here and use this as a triangle and find that, and then find this rectangular piece here in the middle, and then add on the semicircle. Lots of different ways to go, but I'm going to let you do that. You're going to go, and we're going to let you solve this question. So I want you to do your best in solving this question, and then I'll be asking for your answer, and we'll see how you did. Thanks. Good luck. All right, and we're back to find the answer now. A couple things that I would point out on here. This is what we're going to call base 1 or base 2 of the trapezoid. It doesn't matter. And we're going to show it the trapezoid way. So the formula for the area of a trapezoid is 1/2 base 1 plus base 2 times the height of the trapezoid. So these pieces need to be found in this trapezoid. This can be base 1 or 2, doesn't matter. This is the other one, that's the other base 1 or 2. So then we're going to add those two bases together. So 6 plus the 16 is going to give us 22. That's going to go in here. So we're going to get 22 times the height of the trapezoid, which is right here. That's 7 times 1/2. Now in my head, I'm going to move this 1/2 times 22. I'm just going to call that 11 because 1/2 of 22 is 11. I'm going to multiply that by 7, and therefore the area of the trapezoid is going to be worth 77 square feet. So 77 feet squared. Now, we know the area of the trapezoid is 77 square feet, but what about the semicircle? This semicircle is right there. And that semicircle has a diameter of 6 feet. But that 6-foot diameter means we have a radius of 3. So we're going to plug in a 3. And we're going to square the 3. We're going to square the radius. That means 3 times 3. We're going to multiply that by pi, which is 3.14. And we're going to get 9 times 3.14, which is approximately 28.26. 28.26. So if we add the 28.26 plus the 77, we end up with right there 105.26. So 105.26, and that's going to be feet squared, also known as square feet. So approximately 105.26, or just a little over 105 square feet, is the area of that figure. Now, could you have done that with a triangle in the corner, found a rectangle in the middle? Absolutely, that would have been a doable situation. You could have definitely done that. If you did it that way and got the same answer, I applaud you for that. Well done. Let's do another one. All right, and we're back. Here we are with number 3. So number 3 says a figure is composed of a triangle and 3 semicircles. 3 semicircles and the triangle. So my first thought is going to be that I want to find this triangle. Need to find the area of that triangle. And then I'm thinking to myself that this circle right there is probably going to sit nice side by side with that one. If I were to collapse those together, they both have a diameter of 20 and diameter of 20. So those 2 half circles are going to equal 1 full circle. And then I've got an extra half circle right there. So just an extra semicircle. So really it's going to be 1.5 circles. It's not a very good one, but 1.5 circles. Okay, there we go. It's a little better. And if I can find the area of 1.5 circles, and I can add that to the area of the triangle, I need to remember my formulas, or if I need to, you can look up your formulas. But I would encourage you to stop right now, like the video is going to make you do, and go solve this question. Check it out. Hopefully you get it right. If you don't, the video answer will play right after that. And this is really good learning because there's going to be questions just like this on your quiz or your assessment or whatever's coming up that's going to have a score related to it, and make sure that we understand what we need to understand at this point. So good luck. Let me know if you have any questions after this video is done. Okay, and we're back. I put up there the formula for the area of a triangle. That's the base times the height divided by 2. You can see here that the base of this is 20, and that the height of the triangle, and remember the height of the triangle is always going to make that right angle movement with the base. So the base and the height always have to make up 90 degrees. So the 20s, remember those are slant heights. Those would not count. Slant heights when referring to 3-dimensional objects. But basically, we don't want that 20. We know that that height right here also has to be smaller than the 20. And so this makes a lot of sense. The height is 17.3 for the triangle, because that makes a lot of sense. This one's coming straight down. This one's going at an angle. So that angle's 20 inches is clearly going to be longer than going straight up and down. And that's the 17.3. So I can do the base times the height. That's 17.3 times 20. I can then divide that by 2. But what I'm going to do, mental math, watch this, Mr. Simmons is going to try to impress you here. So 20 over 2. I'm going to look at this 20 over 2. I'm going to say 20 over 2 is 10, because 20 over 2 is 10. So 20 divided by 2 is 10. And then I'm going to take that 10, I'm going to multiply it by 17.3. And that 17.3, I'm just going to move my decimal one spot to the right. Anytime I multiply by 10, that's all I need to do. So my answer is done in my head, not in a calculator. But I can guarantee if you did it in a calculator, you got the same answer. So 173 inches squared. 173 inches squared. Maybe you solved it like I did. Maybe you didn't. But that's the first part. That's just the triangle. That's going to be all the area found inside of here. So now we need the 3 half circles in addition to our answer. All right, so now let's take a look at the circle piece of the puzzle. We know that the diameter all the way across is going to be worth 20 inches, and that means that the radius is going to go from right here to the outside, and that's going to be just 10 inches. So we know the radius of these circles is going to be just 10 or 10 inches. So that means I can drop in a 10 right here, and this is going to make it a nice, easy number to work with. The 10 squared times pi, we know pi is going to be 3.14. 3.14 will equal the area. So right off the bat, we should make this real simple. 10 times 10 is going to be 100. So this is going to be 10 squared. We know it's 100. If you want to multiply anything by 100, you can simply move your decimal 2 spots to the right. And that means that that 3.14 is going to become exactly 314. So here we are with the approximate answer because we used pi. So it's kind of an approximate answer. But we are looking at 314 inches squared. What we need to remember, though, is that's going to make for a full circle. So that's going to make one full circle. We need to get half of that value because we still have this guy to deal with, right? This is the full circle up there and there. But we need to get a half circle right there in the mix. So I'm going to do 314. I'm going to divide that by 2. If I do 314 divided by 2, we're going to get 157. So 157 is going to be for the half circle, which is right there. And then if we put the 314 and the 157 together, we're looking at a total of 471 inches squared. And that's going to be for the 3 half circles. That's going to be for the 3 half circles. So for the 3 half circles, we end up with 471 inches squared. But then I'd have to put that with this answer right there. So if I put that with the triangle, we get 471 and 173. And we end up with a grand finale answer of 644 inches squared, also known as square inches. So 644 should have been your answer for that last question. If you're getting these right and you went 3 for 3 today, I'm super proud of you, and your math teachers are super proud of you. I'm super proud of you. That's a wonderful job. So these 3 questions are certainly ones that we want to be comfortable with, but there's so many different combinations of shapes and composite figures that we could be figuring out, and now we know how to do not just triangles, but rectangles and squares and parallelograms and trapezoids, but now we've added circles to the mix. We can find the area of circles. We can find the circumference of circles. I think we're doing pretty awesome with this. If you have any questions, please reach out to me or your math teacher. And I thank you very much for joining.